The software landscape's evolving quickly, so I want to talk about the large language model and the perfection of your production schedule.
You got to have good data, you've got to have good scheduling, and you've got to just continually push people to think differently.
You have to line up all the stars. Everything has to be perfect for you to really nail scheduling. I've been preaching about the benefits of Monte Carlo simulation. In practice, it has to really replicate what your real manufacturing operation is doing.
Welcome to the Next-Gen Metal Fab podcast. I'm your host, Tim Heston. In each episode, I'll be joined by a rotation of co-hosts. Caleb Chamberlain from Oshkosh, Cody Lee from Everyday Technologies, and Lance Thrailkill from All Metals Fabricating. Together, we'll talk about what the future could look like for precision sheet metal and tube fabrication.
Want to level up your manufacturing or metal fabrication career? Fabricators and Manufacturers Association connects you with the education, training, and community you need to stay ahead. As an FMA member, you'll get access to exclusive resources, industry events, and a network of professionals who share your passion for making things better. Join today and start building your future in manufacturing at fmamfg.org. And now, back to the episode.
Thanks so much for joining us for this latest episode. I'm joined again by Caleb Chamberlain. How you doing, Caleb?
I'm great. How are you, Tim?
Oh, just great. And Lance Thrailkill at All Metals Fabricating. How you doing?
Doing great, thank you.
Just wanted to see how business is in this new year. The entire country was covered in ice and snow, so things are running behind at a lot of readers, I understand. But yeah, Lance, just kind of give me the update. How's been your January?
Good. We had a real big influx of business at the end of our Q4 last year, which is not normal. And then we had a short month in November and a short month in December with the holidays and such. So feel like we're constantly playing catch up. So then this freeze we lost in here in Texas. If the roads are icy, everything's shut down. Nobody knows how to drive on ice here. So we basically lost all weekend, and through Wednesday, we're finally back up at full production yesterday, which is a big relief. And so we lost about a week, which definitely hurt. We were on track to meet or beat our goal for this month, and now we're not going to hit it. But we got an opportunity to make up for it next month, and then have a record month next month.
So Caleb, out in Utah, Oshkosh, so kind of describe your January for me as far as, obviously Utah is in a far different situation as far as the cold infrastructure, but just kind of bring me through how business has been the last few weeks.
Yeah, pretty similar. We saw a big spike in Q4, which we don't usually see, led by a couple key industries, I think. A lot of defense, a lot of energy, and some infrastructure stuff. And then going into January, we're on track to finish the month at like 73% ahead of where we were last year this time. So it's really booming.
But yeah, kind of wanted to lead this off. FMA recently released their Forming and Fabricating Job Shop Consumption Report. It's a survey among FMA members and other industry stakeholders about the new order activity, which is up for many, for the majority, in fact, but also kind of their investment strategies going forward as far as what their greatest needs are, especially automation needs. And over the past few quarters, we've seen what's interesting is bending take the lead over blanking, where more automation on the bending front is becoming at the top of many folks' mind. And then, of course, the software category, which with quoting at the top and ERP and especially scheduling.
So this is shops reporting that quoting is top of list as stuff that they want to automate and streamline.
Yes. So 46%, in fact, quoting as a strong lead over every other software function, depending what that function is. The software landscape's evolving quickly. We actually cover a very small Texas shop, I think outside Dallas, that actually had a weld foreman write his own software. Because he had experience with Python and did it as a hobby. And now they're developing their own ERP system for this small 10-person shop. And it's a unique shop. It's not a typical, they have a variety of jobs that set them apart from other job shops, very similar to very small shops. They have specific customer mixes. But it's a very interesting approach because They kept trying to get past QuickBooks, beyond QuickBooks and beyond the Excel sheet, and they're doing it themselves.
I think that making your own MRP, like your own tool to help manage production, like vibe coding, something like that, is a fantastic idea. I wouldn't recommend moving your general ledger off of like QuickBooks or Xero or NetSuite or whatever you're using. Um, it's super high stakes, software of record kind of thing that you got to be careful with. But man, that MRP stuff, if you can customize your own software for your own flows, it's like a superpower. So that's
Right.
awesome. That I think
Yeah.
people should totally look into doing that. It's lower stakes too.
Right. Right. And he also had the benefit of, it's a smaller operation, and it's also, I guess, a quote unquote software greenfield where they never had software before. So other than Excel sheets.
Yeah, that makes it easier.
Right, right. So Lance, kind of bring me through your, riffing off this survey, your investment strategy going forward. What are you? I know you said you were on the look for an ERP upgrade and other software upgrades. So kind of bring me through your software and hardware roadmap for 2026 and beyond.
Yeah, absolutely. Thank you. So, yeah, to really it started kind of end of Q4, we we invested in Cloud NC, which is a machining AI-based machining software for programming mills. And so we were implementing that currently. Excited about that. And then on the cutting and bending, we decided to move forward with an automate that have AI, and we were evaluating that in Q4 and just we're going through training. Kind of we did the first training, and now they're coming on site in the next week or two to help us with streamlining production programming for the sheet metal side. And so that's exciting and making that investment. That's a challenge for us is when we get, unlike Caleb's business, it's like we get 80 unique SKUs at once. That programming actually becomes our biggest bottleneck. And so being able to batch process and program for multiple machines and move it from one machine to the next was a key thing for us. And so while we've been very advanced in virtually every aspect of our business, that was one where we were a little bit still antiquated. And quite frankly, I just think sheet metal fabricating software in general for programming, with bin deductions and all those factors, it's difficult. It's more difficult to truly automate it and let AI, which you would think machining, that's way more complicated, but apparently not. And I think a lot of it's attributed to, bin deductions. And so we're moving forward with that. That's this year. But right now, actually to Caleb's point, we've been developing a scheduling software. We're using Sky Planner. It's supposed to be done. It's stood up, but we're massaging it, so to speak, before we release it to production. And so we're in the final stage of that. Should be done in the next couple weeks and really start testing that. So that'll be, depending on how that goes, that will either extend our timeline or our need or sense of urgency for moving ERP solutions, as scheduling is our biggest pain point with ours. And so we'll see how that goes. I have a pretty high confidence level that it's gonna be better than what we have. And so, but yeah, ERP, our goal is to identify which partner we'll be moving forward with by the end of the year and have an implementation plan in place. So we wrote that goal to exceed it. Ultimately we would like to move forward this year with a new ERP solution. But if the Sky Planner really works really well and our large language model that we've been building works well, we may not need to make that move as quickly. So we'll see how that goes. And then on the machine front, we're really looking at automating storage, our storage. So really, our footprint is a challenge for us, and so creating more floor space and looking at some different. It's not as much about the automation, although I think it is nice until it goes down, of course. Having material storage, but really what it does is it condenses the footprint and reduces our number of racks. And so by doing that, we can add enough space for another cutting machine, which is a big need for us. So that's what we're doing this year. And then we're looking at expansion plans. We're in talks with a customer of ours about standing up a integrated cut to bend solution at one of their facilities that we would operate and own. So that's a pretty exciting development. So whether it be that or building on the lot next door that we have, where we're going to decide this year which direction we're going to go, should have clarity this quarter if we're going to move forward with our customer or not, and then can make the plans accordingly.
There's a lot to unpack there. There are two elements I heard that kind of stood out to me. One is the embedding of your operations into a customer facility. That's fascinating. But first, I want to talk about the large language model and the perfection of your production schedule. So bring me through that. Like, what's your current production schedule now, and what do you aim it to be with this new platform?
We have a finite resource scheduling software, and it the limitate where it really becomes a challenge. There's some quirks in it that I don't like. To get super technical, one aspect of it is they treat queue time as a block in time. So, in order to schedule jobs correctly, you want to have some queue times in there because it's not going to literally go from one department to the next and hand it off and be done. Maybe in Caleb's shop, but everywhere else in a production facility, it doesn't work like that. So you want to have these queue time buffers, right? Well, the issue with our software is that it treats as a block of time. So if you have a 4-hour queue time, then and let's say a 1-hour setup and a 5-hour run, now it has to find a 10-hour block of time, which what it should be is that once that 4 hours is elapsed, it's only looking for that 5 or 6 hour block of time. And so that's caused a bunch of frustration with us. Another thing, that aspect of it is the rescheduling of a long running job that you're clocked in on. And so what I mean by that is it has a calculation method that schedules the job out based on how many parts are complete. So if the operator's not entering the exact number of parts complete correctly, there's a percentage complete function as well, but it only works on a quantity one, which is the dumbest thing I've ever heard. So they can enter percentage complete, but it only actually for example, like if you're doing a weldment that's a 60-hour job and you're not going to start getting complete parts till hour 50 and you're entering percentage complete, it's for that first 50 hours, the first 4 days, it's going to be kicking that out 2-3 weeks till completion. And so that hoses up everything else in the system because it's occupying that resource for weeks and thinking that job cannot be done. And then that affects every other job. So those are the two biggest pain points for us regarding scheduling, I'd say. And so with the new software we're building, we think that those two things are solved for. We're going to start with just saying, rather than doing any recalculation method, just assume they're going to finish in the amount of time that was set. Because our shop generally operates close to 100% efficiency in terms of the amount of time. Like there's some jobs they may go way over, there's some jobs they may beat, but it all kind of washes out in the end. So we're going to start there and then dial it and tweak the recalculation method. So that's what we're doing on that front. And then do you want to talk about the large language model as well, or?
Yes, so that's a separate project, or?
Yeah, it was a separate project. We'd hired an AI intern last August, and he had started on that one, and had gotten it's stood up. But we had difficult time getting, our ERP solution to kind of pull the curtain back, so to speak, and be able to understand the calculation methods, and the tables. And so we got all the tables finally, but getting for example, throughput, right? Like how they calculate throughput versus how we want it calculated, and just understanding which tables it's pulling from which things to be able to generate the correct information, which data is only good as is accurate, right? And so we've got it probably 80% of the way there, and I'm confident we can get it all the way there. We've been talking to some people at our ERP solution, and hopefully can get it to the finish line. But I had him pivot to the Sky Planner project to put that one on hold, because I was like, this is our biggest need, this is our biggest pain point. Let's solve this and then come back to that. And so that's what he's been working on the past several months, and should be close to deploying in the next week or two. So excited about that.
I like it. AI intern. I think the industry will see more and more of those because you've got these folks who quote unquote grew up with the technology. They didn't really grow up with it, but they've probably had more of a chance to fool around with it than a lot of people who have been working day jobs for years. Is this guy at college or is this or is
He's
he
a
in?
yeah, he's a senior here at UT Dallas, and actually I've already told him, hey, I want you full time. So he's this is wild for us, right? Because I mean, it's like, what are you going to do with this, software guy full time, right? But like that's the world we live in now,
That's
and
right.
I've learned so much from Caleb, and thankful for that. But and also we're going to have him to spearhead the ERP transition as well. So but we'll find ways. We haven't even gotten into like workflows of account managers and workflows of people in the floor to see where enhancements can be made. So I mean, I think it's a no brainer for any shop. We put an Indeed listing up, but we had 50 applications like overnight. And so it was, and I mean, it's we're not having to pay him a lot of money, and I think he's going to add a ton of value. So it's something that every shop should consider, honestly.
Yeah, that's great. So Caleb, kind of bring me through your scheduling methodology over the past few years and how that's been perfected under your vastly different business model there.
Well, I wish I could say we'd perfected it. We definitely haven't perfected it yet. You have to line up all the stars. Like everything has to be perfect for you to really absolutely nail scheduling. I've been preaching about the benefits of Monte Carlo simulation for years, and we still don't have a super great solution that uses that. Um, the challenge is that like the thrust of the Monte Carlo simulation is that you're not just saying, oh, this part takes this and this part takes this and maybe some buffer time and you Gantt it out and there's your thing. Monte Carlo says, well, based on the properties of this part, it could take a minute or it could take 10 minutes, and here's what the probability distribution looks like across all the possible times based on historical information. And we're going to pair those kinds of time models for every single process. We're going to pair that with a decision-making heuristic at every process that says, here's what to work on next. And then you run that through to completion. So it's like an operator's at a workstation. The heuristic is what says work on this part. And then the time model is what says here's how long it takes in this simulation. You run that to completion. You even simulate incoming orders statistically. And then at the end, it says, hey, 20% of your order shipped late. And here's where your bottleneck was. So it doesn't say this will ship late, but it says, hey, based on statistical averages, we think there's a high risk of shipping late. And that gives you a chance to like, once you have that simulation, you can like experiment with heuristics design. So like you can tweak the part selection criteria and then rerun the simulation. And then it could say, hey, you shipped 5% more on time. It's really awesome in theory. In practice, if you're sampling from models, your models have to be good. And for your models to be good, you have to have good data. And, we've started plumbing into the depths of all the data we've collected over the years and found that a lot of it's worthless. Um, because like an operator will forget to like start a timer when they're working on their part in bending, and they have to start a timer to finish it. So right at the end, they'll like start the timer, stop the timer, and push it through. So this part took half a second. All right, well, so we've got a massive data cleanup problem. Our laser time models need to be improved. Um, so I think we'll get there. I do think that this would be the solution, but I think for it to actually work, you know, and then in practice, it has to really replicate what your real manufacturing operation is doing. Meaning, if you're running a part selection heuristic, it has to match what the operator does, which really means all of the work consoles on the floor that tell the operator what to work on next, it has to take the decision out of their hands for the most part so that the simulation matches what's happening on the floor. And we haven't like got the, institutional like inertia to want to just take the decisions away from operators in each location.
I mean, you guys have it as good as anybody in terms of what you're accomplishing. But is there any point of arrival on anything?
I think we'll probably have like literally we'll have like quants. Like we'll have people who just like analyze data and generate models all the time, full time at Oshcut. Like a job that probably doesn't exist in most manufacturers, but we'll probably have them because we have all these models and we want them to be good. But the other thing that's challenging is that you build this, you're building like, I hate this phrase, this digital twin phrase, but you're building a digital twin of your digital systems. So like if you want to change something about how production works, you have a lot of software to change along with it to make sure it still matches. So you kind of calcify around a particular way of doing business, and that's one of the reasons we've drug our feet on really going all in on this tool. Um, and I think we'll get more and more of that direction eventually, but in the short term, it's just like, you know what the real scheduling solution is? It's to have excess capacity all the time. If you always have excess capacity, it basically doesn't even matter. And that's expensive. And that's another problem. But I mean, we just ordered another $6 million of equipment to expand capacity and capability here. And that's part of the reason. I was like, am I going to spend another $1 million developing and fine tuning the scheduling tool, or maybe I should just get over capacity, then we can, support our rapid growth and worry less about scheduling for now. I mean, I don't know.
Well, and I think too, the scheduling, like the more compact your schedule is, like what our schedule works fine when we're caught up. But like when you're behind, it's like it just breaks completely. You know what I mean? It goes back to having that excess capacity into it. And it's like, so, I think that was a wise decision because without that, it's difficult for any schedule to work. Like most of our people work 55 hours, but we'll only schedule them to like 42 and a half or something like that, depending on the department.
The problem with excess capacity is that you kind of have to have a crystal ball. And of course, nobody has that. We entered 2025 thinking, yeah, well, we're seeing kind of some tapering off of growth, but we're also continuously changing and improving and expanding our services in our addressable market. And it broke all our expectations, And in 2025, uh, we grew like 60% year over year instead of 20%, which was the expectation. And we had CapEx plans based on the 20% growth expectation. And of course, blew that out of the water. And it came to a head in Q4 when we had 3 of our 5 lasers down and record demand. And we shipped one of 5 orders late. We're shipping like 150 orders a day, and 1 in 5 went out late. And we actually refund customers when they pay us extra to ship fast. So extraordinarily expensive, and it's all because, how do you plan on having excess capacity? You basically have to charge more for it, but people are also cost sensitive. So it's a very, very hard tightrope to walk on, at least in our model.
Yeah, I last the last scheduling story I did when I interviewed the source. This guy was he was a software guy, but I geeked out on Little's law and Q theory, and so how do you guys manage and observe the amount of work in process you have between? So because Little's law states that the more queue time you have, larger amounts of work in process between processes, then the longer it takes for that blank to ship out the door.
Mm-hmm.
And so how do you work that into your system where, and of course you got theories of constraints and lean manufacturing, which is, this is all tied to that, where you try to increase that part flow velocity throughout. And if you do that, then scheduling in theoretically becomes simpler. But yet then these philosophies were all written for low product mix, high volume operations. So I'm kind of curious how that applies to y'all.
Yeah, it applies in spades. And so what you're describing is there's a bunch of math for it, and it's all like provable and well defined, but it's more than that. The math isn't saying the queue time will be longer because of volume. Um, well, the queue time is longer because of volume, just like from first principles, but additional stuff happens on the floor that makes it even worse. Like if you're burying and creating giant buffers and creating confusion on the floor, we have what we call seek time, which is the amount of time it takes an operator to go and find the next part they're going to work on and grab it. And like seek time grows quadratically with the number of parts that are in a buffer. So it's not just that there's more stuff to do, it's that everything takes longer because there's a lot of stuff to do. So it gets really, really bad. And we don't have a super, I mean, the solution is to minimize buffers. I mean, Toyota figured that out forever ago, and that's why. It's just if the manufacturing operation is structurally simple, then you don't have to spend a bunch of time trying to figure out how to optimize waste with software and algorithms and stuff. This actually goes back to, we're talking a lot about this internally right now, but like cell-based manufacturing, like a bunch of tiny cells versus production centers, kind of like we have today. We have all our lasers, and then we have all our press brakes, we have all our finishing machines. And the problem is you take a bunch of volume from all this equipment and you collapse it down into a buffer shelf somewhere, and then you have to find it and bring it out again. There's people hunting for parts. The entire operation gets way more complex. And we pay a large cost in like lost and, missing parts because we're set up that way right now. But with cell-based manufacturing, it's just like, well, no, I mean, the part's right here. It just came off that laser right there, and now it's right here. And you limit how much you let go into any individual cell. The reason we didn't set up that way in our current facility is that it's less capital efficient, because if you run out of laser capacity, you just add a laser if you have a laser department. But if you need to add a cell, well, now it's like you're creating this discrete unit of capacity that may or may not have feature parity with your other cells, and you've got to try to do all this load balancing stuff. We're thinking heavily about this right now because managing the complexity is becoming really challenging as our volume increases.
Yeah, actually, I'm just right now. I'm finishing a story about a cellular manufacturing story on a high product mix pipe fabricator, which happens to be in Houston, and they just split into two value streams with two work cells, and a lot of it's about the cultural transformation because they have two welding stations, and one welding station does certain diameters of pipes, and another station does other diameters of pipes. And these welders are going, wait a minute, why is this idle? What we should fill this up. This can accept this kind of pipe. No, that goes against the rules. It goes through this cell, this value stream. And it didn't make sense as far as, I mean, OEE numbers went down, the utilization went down. It didn't make sense. But then the guy who's leading this project said, trust me, it's going to make sense because we're going to increase flow time. And at the end of the project, so they used to ship $600,000 a month. Now they're doing 1.2 million. So more products
the
are
same
being
amount of people in the same equipment.
That's 15 people in the shop, and $1.2 million a month. And the key to it is twofold. One is they're perfecting the flow time, so the velocity from order to ship you reduce that, and so then you increase your capacity that naturally, because your flow time is lower. And then at the same time, they've used that data to direct the kinds of pipes they sell. So they say, wait a minute, this is especially profitable. So I'm going to really concentrate my sales efforts on these kinds of pipes to fill the shop with this kind of work, because I know this is the most profitable kind of work I can. This is my specialty as a pipe fabricator. And so this is my universe that I can really, shove through and really be profitable. They'll always have that long tail of other things because they are a job shop, but it's help directing that sales effort. It's interesting, but at the same time, there's there's all sorts of challenges. That's a pipe fabricator. So we need to get to a sheet metal fabricator. Like I talked to another shop who had put 7 cells. This was Metcam here in Atlanta years ago. Had 7 cells throughout the whole facility. But they had the cut bend cells, they had different bed lengths for each press brake. And then they found themselves having all sorts of exceptions. And so then from a standard flow, they went right back to the spaghetti diagram of everybody moving everywhere, trying to get. So they rearranged again. So there's no easy answer. So it really depends on the kind of operation you have. But yeah. So Lance, like, how do you guys tackle WIP, and how you kind of measure it? Going, all right, how much work in process do we have? How can we manage it so we can have optimal equipment utilization, but make sure we're shipping as much as possible in the least amount of time?
Yeah, I've always been intrigued by the cell model. I think Caleb, I think it'd be really good for your business, honestly. And part of the downside is you're managing multiple schedules. Then I'm like, we can't even manage one schedule, but I think managing 5 schedules with 100 jobs in them would be much better than managing one with 500. Then, I mean, you're just seeing all that clustered in together is part of the challenge. Um, and just because there's no real great way to view it all succinctly. But yeah, I've been fighting this. This is hilarious because this is like I've been fighting this since I got here at All Metals. Historically, our people, like, what was in their queue was like their safety blanket. That was like they always wanted to know that they had their overtime because they could see their work. And even the account managers, like, they wanted jobs to flow through the shop slowly. And I'm like, I mean, it comes up probably once a month. So, some account managers pissed off. He's like, I had this job 6 weeks ago and we're just starting it the week it's due. And I'm like, well, how many hours you're on it? That doesn't matter. I'm like, yes, it does. It matters a lot. Was that a 5-hour job? Is it a laser cut only job? Is it a laser cut and bend job? Like, we don't need to be starting on that. Y'all complain about the floor space all the time. The only way to address floor space is to increase part velocity. The way to increase part velocity is by shrinking queue times, holding work in. And this is part of the programming solution of, like, we would program a part and release it. We would dynamically nest. If it was an assembly, we would do it, or if the operator sees, oh, I'm about to run these materials, I'll bring it back in and dynamically nest it. Or if we had some, like, constant continuing jobs that we knew we could always dynamically nest. But, like, you should be dynamically nesting everything. If you're holding jobs in production and programming rather, and waiting to release whatever you need to run that day or the next few days, you can really control that better. So this is just a constant battle of, like, fighting against an old school mindset. But as you do that, the other catch 22 of that is the schedule has to be dialed in. Right. And when you don't have excess capacity in your schedule, it's really difficult to dial it in. And so I really hope that this software is going to help us have better visibility, better accuracy on our scheduling, because that all this goes hand in hand, and it's all causes a lot of frustration for a lot of people. But that is something we're constantly fighting. We measure queue time. Every department on their queue monitor has their average queue time set for that quarter, what they're averaging, and they're encouraged to, we set the standards and encourage them to work that down. But that can even get thrown off when somebody puts a job on hold, or things like that. Customer moves the data out, that can skew their data. We actually used to do it monthly, and I was like, we got to change this to quarterly, because one job can skew a department's, if somebody puts something on hold or moves it out. So that's something we measure, and we're encouraging them to get it down. But it's a constant battle fighting that mindset. And I get it, because, like, if you entered a job 6 weeks ago and it's a little nothing job and it's late, I'd be pissed off too. If that was my customer and I'm having to explain to them why, and I went ahead and got that extra lead time that I didn't really need. But really, we shouldn't even be quoting that big of a lead time for that job if you really want to get down into it. So, but I think some customers just, have that built in, and that's what they send. So it works out well until you miss the date. And those are the tricky thing is, as your schedule gets compacted and over capacity, those are the jobs that fall through the cracks, right? Because the other jobs that have a ton of work to go on them, you need to get on those. And so those are on the people's radars. And so the ones that fall through the cracks are the ones that, when you entered it 6 weeks ago, it's scheduled perfectly fine, and it backwards scheduled, by the way, so that it didn't need to start until the week that it was due. And then now the schedule compacts, and then it can't schedule that job in there. And so now it's fallen through the cracks. And so, these are the challenges of it. And you just got to keep, I think it goes back to there's no point of arrival. You just got to keep, you got to have good data. You've got to have good scheduling, and you've got to just continually push people to think differently about the way that they've been trained to do it. So,
Right. Yeah. It kind of reminds me of a shop years ago. There was a press tour in Japan. I got to visit some Japanese metal fabricators. And I remember visiting this one shop. Land is at a premium, and this one shop is on the second story. I don't know how they got some of these machines on the second story of a building, but they had. Um, uh, I looked at the punch center, and this was on the first floor. The punch center, and the punch center, they had skeletons coming off, and my gosh, the web sections were huge. I mean, the utilization was just haphazard. Like, what are you talking about? Well, and so I asked them about this, and they said, "Listen, these are for tomorrow's jobs." And so we're going to ship this stuff tomorrow, and that's all we nest, and we don't care. And as far as remnants, why don't you handle the remnants? No, because that takes too much time in our business model. No, it's just we don't care about utilization. We care about shipping quickly. And they had to because they couldn't have he said they couldn't afford the whip because they literally had no space. They were just it was just this cramped operation, and they had a bunch of value-added assembly at the end, and so they were forced to do that. And then another shop I've covered where they literally delayed the order release for everything to make sure that it spent as minimal queue time as possible. Now, the challenge is they gave up opportunity for that because, like, you quote something, but then if you have multiple due dates, well, then if you have downtime here and then a last minute order comes here, you don't have capacity to ship all at once. So it's
Mhm.
an interesting puzzle that I don't know will ever solve completely, but who knows? Maybe an LLM will eventually, or an AI model will. Lance, I wanted to circle back to one last item that you mentioned, which was becoming embedded into a customer facility. So, what's the thinking behind that, and kind of what the potential you see for long-term growth for perhaps any fabricator that could embed themselves into a facility? That's interesting.
Yeah, it's a customer of ours. It's in the data center space, and a lot of those companies are getting their own fabricating equipment. We were with them from the beginning, so sales zero, and now they already have 200 million on the books for this year. They sell a lot of switch gear, so a lot of just pass through. But the idea is, yeah, I mean, I've preached to them, I think, long enough that they don't want to get into fabricating. So, and I was, it's true. If I'm them, I'm like, hey, I want to be focused on selling and designing and moving quickly. And you don't want to just manage. Sheet metal fabricating is 5% of their business. Granted, it's so impactful, right? It's like the engineering that goes behind it. You need all those components to sell all the electrical equipment that goes with it. So I think it feels like such a big pain point to them. And I'm like, hey, if you're the one doing it, it's going to feel like a lot more of a pain point. And so I've just been telling them for a long time, and we just have such a great partnership that they've always kind of promoted, and we do this with all customers. We're like, hey, this is your shop. You bring your customers here and treat it like it's yours, and we're partners. And so one is, I think, them wanting to be able to showcase that they have their own fabricating equipment in house to their customers, and then them not wanting to bear the burden of the all the skilled trades and the learning curve of all these things. They just want to be able to say, hey, you guys come in and operate it. And so we're working out the details of a JV. We have the need for additional capacity. They are also a challenging customer because their way to win business in their market is, having been a startup, is speed to market. And so, they'll need us, like, just this week. And I was reaching out to Caleb to help see if he could help save me on this project, because they're like, hey, we need these 80 SKUs in 3 weeks, and I'm like, we're behind from the holidays, and so we had to pass on that opportunity. But with having a line in their facility, this will allow us to take that pain point out of our normal production where they need things really quickly and operate it in their facility. It'll give us additional capacity. Also, kind of premier market us as a data center solutions provider. And so we'll see if it works out. I'm excited. The ability to to not have to do construction or go into a big long-term lease on a big building. But it'll present challenges, and this is what honestly will pull the ERP solution in quite quickly, because we have an on-prem ERP solution, and so that'll be a challenge for having multi-site. And so that'll probably pull that in much quicker if that deal goes through, which I'm pretty confident that it will. And so yeah, it's attractive to us because we're going to be able to get equipment and space, and where that's a challenge for us right now is because we have just limited space.
All right. And Caleb, I wanted to dovetail over to you as well. As you mentioned, you're looking into the potential of cellular manufacturing. How would it look in your business model, and what have you brainstormed with your team? Is like, all right, especially now that you've got tube. So kind of bring me through the value streams you're kind of thinking of, or have you not gone that far down the path yet?
Oh, it would be a mixture of cellular and more department based. You're not going to sprinkle 60-foot long tube laser inside a cell, for example. Um, so there would have to be some downstream stuff. Welding is similar. We've been doing some piloting on welding, and you're probably going to benefit from having welding downstream, since maybe it needs tube and maybe it needs sheet metal, and then the problem really becomes, in the example that you gave, where like on-time utilization dropped and all this stuff. Yeah, that's the problem, is you don't get your ROIC kind of drops in theory, because you're not getting as perfect utilization out of all the machines that you have. But to mitigate that, it becomes a routing question, like which cell gets this work or this part. And that's going to be based on what each cell is capable of doing. Like maybe there's a laser only cell and it's literally laser final inspection. And so you have all these different cells, and now you're planning equipment purchases and layouts and optimizing routing to try to optimize utilization, even though you've got this kind of fragmented space. But I mean, some weeks we scrap today 3% of parts that we make, 3 of every 100 parts that we make, for various reasons. And a top 3 reason is always, we can't find this thing. Like, we don't know where it went. And every time that happens, you know that somebody's walking around on the floor hunting for a part instead of doing value added work. Like, it's such waste. And then of course you've got to requeue it, and you've got to put it on the laser again. And now you've got a part sitting on a shelf somewhere that was scrapped in the system because nobody could find it. And it's sitting there collecting dust, and somebody eventually runs across that and is trying to figure out what the heck it is while it's cluttering the shelf. So yeah, I mean, we're shipping 35,000 parts a week, and we're losing, low single digit percentages of them somehow on the floor. So
See, that 35,000 parts a week. See, that's the great coda there, because I've talked to so many lean consultants and continuous improvement consultants say, why don't they just do this or that, work cell, etc. I even talked to one shop that actually was a beautiful example of lean manufacturing cells in metal fabrication, where they had blanking. It was almost a two-factory approach, blanking on one end, then that would feed a buffer that would actually feed a bend hardware insertion weld grind cell for certain different value streams for different product categories or product families. But again, that worked for certain product mix, and they had a specific product mix. And if you need, whenever I talk to consultants, I say, yeah, how about 35,000 different jobs? It's easier said than done. So yeah, we've been nerding out here for a while here. So thought I'd just wrap this up with some final comments. So Lance, where do you hope to be on December 31st, 2026?
Well, we're shooting to break our record year sales. Hope to open up a second location, or at least have our plans for a second location. Have an ERP solution identified, if not implemented. Um, and create some more floor space for an additional laser, which may be solved by the other facility. So we'll see how that goes. But yeah, we're excited. Good challenge. Lots of things to work on. Big picture, and I like the big picture stuff. So
All right, Caleb, what's your crystal ball for 2026? Another 60% growth?
I mean, we're trending that way. I mean, so far we're 70%. It's just a question of whether we can keep up. So we're hiring like crazy, and we've got a bunch of new machines on the way, and we're also launching tube bending. It's not actually fully launched. It's kind of been in beta for a while, but full launch probably next week. So by the time people are listening to this, it ought to be out. We've got another tube bender on the way as well, so we can do bigger tube. And then we have a whole bunch of like R&D projects for ways that we can augment our services in pretty novel ways that we're really excited about. So, and some of them are hard, like, sometimes it's just like get a machine, great. And sometimes some of these new services or new capabilities are like, this only works if we solve a problem that nobody's ever solved before. And we've got a few of those brewing right now, and we're pretty excited about it. So we shall see.
All right. Well, thank you to you both for your time. It's going to be an exciting year ahead. Thanks to all of you for joining us for Next-Gen Metal Fab, and we'll see you next time.
The Next-Gen Metal Fab podcast is a production of Fabricators and Manufacturers Association and part of the FMA Podcast Network. The show is hosted by Tim Heston and Caleb Chamberlain. The podcast is produced and edited by Garrett Slager and Dana Weicker. Additional production support by Dan Davis, Andy Flando, Mike Owens, Billy Culpa, Elizabeth Gavin, and me, Sarah Spring. Thank you for listening.